Hi, my name is Monica, and this is my solution for lead code number 2, add two numbers, which is a medium level problem. So I'll start by reading out the problem. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except the number zero itself. So what does this last sentence imply? It means, like, let's say you have two numbers which are different lengths. Like, for example, number 450 and 5. Instead of it being adding 450 and 005, you're adding two linked lists of a different length. And that does affect the code. And that's actually why I have to have these set of lines. The code is a lot of length of lines, but when you break it down logically, it is a lot of repetition and it just makes sense. So then first of all, I initialize my variables. Carryover equals 0. Pointer 1 and pointer 2 are going to be me adding up the two linked lists. So I'm going to set them to the beginning of the two linked lists. I'm going to be creating a new linked list, which is going to be pointed to by new head, and then pointer new will be at the edge of the new linked list for where you need to add the numbers. And this new linked list will also be stored in reverse order. The first two linked lists are stored in reverse order, and then the new linked list will also be stored in reverse order. Okay. So these lines of code are simply me adding on to my new linked list. So if there's no new head equals list node of whatever value, whatever digit is supposed to be there. Pointer new equals new head. That makes sense. Else, if there's already a new head, then I only have to add a list node at the edge of the number. So pointer new.next is equal to a list node, which whatever digit is supposed to be there, and then I increment 1. So then again, I'm at the bleeding edge of the linked list that I'm going to return. And here I return my new linked list. So this is simple. It's given a digit that's supposed to be there, and it adds to the end of the the linked list that I'm going to return. So next, I have the loop itself. So even though this has OR statements, I'm just going to say this in AND statements. So while there's a digit in linked list 1, and well, I'll say it in ORs. While there's a linked list in while there's a digit in linked list 1, or there's a digit in linked list 2, or my computations before had some carryover, I still have to keep adding numbers to my summation linked list. So, so all of this code is just computing to find the correct digit to add next to my return linked list node. So, for example, if there's only a carryover left, that's what this is saying. Current sum is equal to carryover, then I zero out my carryover. As you could see, if carryover equals 0, the while loop won't even pick up on that. So then that's what it could be. I could set it to anything under 0, but I just chose, or sorry, I could choose it to 0 or a negative number, but then I just chose to set it to 0 because that semantically makes sense. Next, if I'm in the middle of both linked lists, then current sum is equal to all the values plus the carryover. Then I take the last digit of that, %10, that's modular arithmetic. Then the carryover is equal to that same sum, but truncate by 10. So then all the digits after that. And then I go, and because I added up the two digits in linked list 1 and linked list 2, I can increment by pointer 1 to pointer 1.next and pointer 2 to pointer 2.next. And this only gets called if there's a pointer 1 and a pointer 2. Else, if there's only a pointer 1 and not pointer 2, then I do the similar thing, but then I only add carryover and pointer 1's digit. And similarly, carryover equals that sum, but truncated. And pointer 1 is equal to pointer 1.next. So I'm still going through pointer 1, but I don't go through pointer 2 because pointer 2 is is equal to none, which means that I've gone through that